started. This first problem says alright, so the first problem says people buying food in a sealed bag at high elevation often notice that the bag are puffed up because the air inside is expanded. Okay, so what this means is, let's say you have a bag of peas or something that was packed in Florida. In Florida, the outside air pressure is 1 atmosphere, so the inside air pressure will be 1 atmosphere inside the bag. And now you take this to Denver. In Denver, the pressure is about 0.8 atmospheres. So the inside air would be at 1 atmosphere and the bag will expand. Till what point will it expand? Yes, till the inside pressure is 0.8 atmospheres. Okay, all right. So anyway, so this problem is, so people find buying food in sealed bags at high elevations often notice the bags are puffed up because the air inside is expanded. A bag of pretzels was packed at a pressure of 1 atmosphere and a temperature of 22 degrees Celsius. When opened at a summer picnic in Santa Fe, New Mexico at a temperature of 32 degrees Celsius, the volume of the bag is 1.38 times its original volume. What's the pressure of the air? Okay, so here is a PV equal to NKT is the ideal gas law, and so PV by T equal to NK. Okay. So in this problem, N is the number of gas molecules, K of course is the Boltzmann's constant. So if the number of air molecules does not change, this ratio should be constant. That's what we are saying. Okay. No matter what you do to pressure, volume, and temperature, this combination should be constant. Okay, so let's call 1 at the packing location. Pressure at the packing location times volume at the packing location divided by temperature at the packing location should equal pressure, volume, and temperature at Santa Fe, New Mexico. Okay. All right, so we're going to use that. Now, of course, you guys remember that temperature in these formulae are in what units? Kelvin. Okay. All right, so 1 atmosphere. What is the pressure of the air? Okay, now also from this thing has to be in Kelvin, but we can keep the pressure in atmospheric units, in atmospheres, and you can even use whatever units for volume, but the temperature has to be in Kelvin. Okay. All right, so what is the pressure of air? We are finding the pressure in Santa Fe, so it's T2 by T1, this ratio, times V1 by V2 times P1. So what we are saying is the pressure at Santa Fe is the pressure, atmospheric pressure times this ratio times this ratio. This is a number times this number, okay? All right, so T2 is the temperature at Santa Fe was 32 degrees Celsius, and that's the initial temperature is 31 degrees Celsius. Okay, go away. So this is 273 plus 32 Kelvin, 273 plus 22 degree Kelvin. and volume 2 is 1.38 times volume 1. Okay. So the pressure at Santa Fe, P2, is 305 divided by 295 times 1 over 1.38. Okay. So let's calculate these factors. Okay, the reason I'm writing it like this is the following. All right, if you notice this, if this is due to, well, the volume increased. Okay, so what this factor is saying is, if everything remains same, if the volume remained the same, if you just increase the temperature from 22 degrees Celsius to 32 degrees Celsius, the pressure would have risen by 3%. That's what that number is telling you. Okay, and here's the volume change because of the pressure decrease. So here's the factor because of the volume change. Okay, so anyway, so that's what this number is telling you. All right, so this is equal to, so P2 is equal to 1.03 divided by 1.38. So 0.75 into 1 atmosphere. 0.75 atmospheres. All right, so if you're living in Santa Fe, the pressure is 0.75 the atmospheric pressure. Okay. All right, so that finishes that problem.